We want to look at discrete random variables in detail now. Now, we talked about that a discrete random variable is one that has finite values, countably infinite values. Now, when we're discussing discrete random variables, we're going to start with what we call the PMF of a discrete random variable. The full form of PMF is probability mass function. Now, what is a PMF? The PMF of a discrete random variable tells you the values that the discrete random variable can take along with the associated probabilities. We know a discrete random variable either takes finite values or countably infinite values. Essentially, we can list all the values of the discrete random variable. So a list with all the values of the discrete random variable along with associated probabilities of each value forms the PMF of a discrete random variable. Right now, what is the notation for PMF? So we write the notation as Px of x. Here, note that this is a capital X, which specifies the random variable in question, and the small x is the value the discrete random variable is evaluated at. Because recall that whenever we're discussing random variables, uppercase letters like the capital X here represent the random variable in question, and lowercase letters represent the values of the random variable. So this is probability capital X is equal to small x. Again, capital X is the discrete random variable we're talking about. Small x is one of the values that it can take. So the notation for PMF is we'll write it as Px of x. What will this mean? This means that we're referring to the probability that capital X is equal to the value small x. So now there are two important properties of a valid PMF. The first is that each probability in the PMF has to be between 0 and 1, and the sum of probabilities in the PMF has to be equal to 1. So a valid PMF needs to meet both of these properties, that each probability has to be between 0 and 1, and sum of all probabilities in PMF has to be equal to 1. Now, the PMF can either be given in the form of a table, right? Remember, like we said, PMF specifies all the values the discrete random variable takes along with the associated probabilities. So the PMF can either be in the form of a table like this, where we list all the possible values of the discrete random variable and the associated probabilities, right? So like we said, the whole goal of a PMF is to specify the values along with their probabilities. So this could be in table form, where you specify the values and their probabilities like this, right? So what this tells us is, and this tells us that the random variable x, from here we can see takes values 1, 5, and 10. With px1, which is the probability, again, this is the notation. This is here we're referring to the random variable capital X and the value 1. Px1 is equal to probability x is 1 is 0.3. And px5 is the probability x is 5 is 0.5. And px10, probability x is equal to 10 is 0.2, right? So over here, we have specified the PMF in the form of a table. We've specified all the values and the associated probabilities. Now note that this is a valid PMF because each probability in the PMF is between 0 and 1. Like you said, the two properties a valid PMF must meet. Each probability has to be between 0 and 1 in the PMF, and the sum of all probabilities in the PMF have to be 1. So in this case, we can see that each probability is between 0 and 1, and the sum of the probabilities is also 1. That is 0.3 plus 0.5 plus 0.2 is 1. Now, PMF can either be in the form of a table or it can be in the form of an equation or formula. For instance, this could also be a PMF. So this is telling us the probability that capital X, the random variable capital X, is equal to the value small x is x by 15. For x values, again, small x is always referring to the value of the discrete random variable, and capital X to the random variable itself. And capital X to the random variable itself, right? So this is telling us that the probability that x is equal to x by 15 for x 1, 2, 3, 4, 5, and 0 elsewhere. So this tells us that the random variable takes values 1, 2, 3, 4, and 5 with px1 is equal to probability x is equal to 1 is 1 by 15, right? Because see, this formula tells us that the probability that capital X is equal to the value small x is x by 15, right? So if x is equal to 1, the probability that capital X takes a value 1 is just 1 by 15. If x is equal to 2, the probability the random variable x takes the value 2 is 2 by 15. If x is 3, then the probability the random variable x takes the value 3 is 3 by 15, right? Similarly, the probability the random variable x takes the value 4 is just 4 by 15. Probability the random variable x takes the value 5 is 5 by 15, right? So if you have the PMF in the form of this formula, this is telling us if I evaluate the random variable capital X at the value small x, that's x by 15. So if x is 1, you just plug in 1 here. If x is 2, you plug in 2, 3, 4, 5, and so on to find the probabilities of each of these values of the random variable. Again, note this is a valid PMF because it meets both the properties of a valid PMF. First being that each probability is between 0 and 1. We can see all probabilities are between 0 and 1. And the sum of the probabilities in PMF is 1. That is 1 by 15 plus 2 by 15 plus 3 by 15 plus 4 by 15 plus 5 by 15 is 15 by 15 is 1, right? So this is what a discrete random variable is. This is this is a sorry, this is what the PMF for discrete random variable is. We looked at its notation, the two important properties of a valid PMF, and how you can write it in the form of a table or equation.